This is page 68 in our notes, and I want you to write this down because this is going to be on your test. This is kind of an overview of Geometry 1. It's going to be on your test. It's also good practice, so I want to make sure we're getting some good practice in our notes of these examples. So I'm going to give you a couple different scenarios here. The first example that I'm giving you, it's going to say the area of trapezoid ABCD is 20 square centimeters. Find the height. So this is a little different because normally I give you everything you need and you have to find the area. And this one I'm actually giving you the area of the trapezoid. They label it by its points and they're telling you the area and they're asking you to find the height. So they're going to give you this picture. So I also want to draw the picture down below. It's going from this blue line over and then it's going to come straight down. We'll go down 3 blue lines. And then this is going to come to an angle over here. And then trace this blue line back, okay? They're labeling this part A, this one B, this is C, this is D, which is where they get the name of the trapezoid A, B, C, D. They just go around there. They make a diagonal between the B and the D here. And then they give you 2 centimeters up here. They give you 8 centimeters here. The height is a question mark because that's what they're asking you to find. So how are we supposed to find the height of this trapezoid? What do we know? What information do they give us? So first off, we know area of a trapezoid is normally parentheses base 1 plus base 2 times the height divided by 2. And that's how you would find the area. Well, in this case, they did. They gave us the area. So what blanks do we know? We know the area. Do we know the bases that we're adding together? Do we know the height? We know we're going to divide by 2, right? So what things are we looking for? What did they give us? Well, they actually gave us the area of 20. And you could call this centimeters squared. They gave us the area. Do we know our bases? Yeah, they're the ones that are parallel to each other. Which one's the height? Oops, sorry, I forgot to draw the right angle. The height is over here. That's what we're trying to find. So we don't know the height, but we do know our bases. Our bases are going to be 2 and 8. So how in the world are we going to solve this, figuring out the height? Are we just going to start guessing? Well, not really. You could actually kind of solve this. You could solve this by combining some of these things together. The left side of our equal sign is still 20 centimeters squared. That really hasn't changed. But could I add 2 plus 8? Yeah, 2 plus 8 is 10. I got to take 10 times the height and then divide by 2. So 10 times height divided by 2 has to give me 20. Well, what if I go ahead and solve 10 divided by 2 here? 10 divided by 2 is going to give me 5 times the height. 5 times the height has to give me 20. And so now some of you are starting to see it. Oh, kind of like when we solved equations before, we drew the line down the equal sign. 5 times height equals 20, so our height would have to be 4. Some of you can just see that, right? What's the opposite of taking 5 times h? You divide by 5. Whatever you do to one side, you have to do to the other. On this side, 5 divided by 5 is 1. 1h is just going to give us h. And on this side, 20 divided by 5 gives us 4 centimeters. Do I label it 4 centimeters squared? No, because height is just one dimension. You're not squaring it. Now, how could I check to make sure that this actually works? I could plug 4 back into the equation to see if this works. 2 plus 8 is 10, and 10 times 4 is 40. 40 divided by 2 would give me 20. Okay, you could plug it in here, you could plug it in here, any of those spots to see that that works. So when given the area and the bases, could you find the height? Can you work the formula forwards and backwards? The next example is kind of a tricky one. The trapezoid they're going to draw here looks a little bit like this. This one comes straight down 3 lines. This one's a little bit of a diagonal and then comes straight back here. So we've got our A, B, C, D. No, this is the same as up above. They give us the same one. We know this is 2 centimeters. We know this is 8 centimeters. We know there's a right angle here. We found out the height over here was 4 centimeters. They give us a diagonal between the B and D. And so now they're saying, can you find the area of triangle ABD? And so you're looking for the triangle of ABD. ABD. They want the area of this one over here. ABD, this triangle here. So it's like, how do I do that? What do I do to find the area of the triangle? Well, there's a couple of pieces of information we already know. We already know the area of this entire trapezoid. They gave it to us on the last problem. So we know that. To find the area of this triangle over here, we would have to use a height, which you could bring out to this red line here, and you could make a right angle for the height. You know the area of this triangle here because you have its base and height. So there's a couple things you could do. You could take the area of the trapezoid, which that trapezoid they called it A, B, C, D, and that area was 20 centimeters squared. What if you subtract the area of triangle BCD, this area, triangle BCD? Well, how do you find the area of this triangle right here, BCD? You've got the base and a height. Well, area of triangle equals base times height, divide by 2. So what is your base and your height of this particular triangle, BCD, right here? Let me kind of trace it so you can see it. BCD, your base and height, make this right angle, 8 and 4. 8 times 4, and then divide by 2. 8 times 4 is 32, divided by 2 is 16 centimeters squared. So if I take 20 centimeters squared, which is the entire trapezoid, and I subtract the 16 centimeters squared, wouldn't that leave me the area of the triangle ABD that they were wanting that's left over here? If the whole thing has to be 20, and this right here is 16 centimeters squared for its area, then doesn't that leave this area over here 4 centimeters squared? 20 minus 16 is 4 centimeters squared. So you take the total, subtract the area of the triangle that you could easily see the base and height to find that one. Some people can see, if the height over here is 4, isn't the height over here 4? Yes. And then the base is 2. 4 times 2 is 8, and then you have to divide by 2 to get your area there. So some people could see that. You could just go straight to area of a triangle and look for A, B, and D's base and height. Base times height, divide by 2. Its base and height are a little harder to see. Its height, 4, is the same as the right side. You just had to draw it out to the side. And its base is 2. So then 4 times 2, that's 8. When you divide by 2, you still get 4 centimeters squared. So either way you want to find it. This is a little bit trickier to find that one, and those are good practices to find the area and then be able to break it down for each